Okay, hi everyone. We're going to continue on with notes where we're talking about angles in circles. All right, we've talked about central angles where the vertex is on the center of the circle. We've talked about inscribed angles where the vertex is on the circle itself. Now we're going to talk about two situations where we will have a vertex that's somewhere on the interior of the circle, and then we're going to have angles on the exterior. Vertex is on the exterior of the circle. So angles inside the circle and angles outside the circle. And at the end, I'm going to be reviewing all of our angle rules for circles. Okay, so here we go. Now first one, we're looking at vertex on the inside. You can see we have intersecting secants here, intersecting secants that create an angle or a set of angles that are in the circle somewhere. It's not necessarily on the circle, not necessarily at the center, it's just interior, okay? So if two secants or chords intersect inside the circle, the angle formed is half the sum of the intercepted arcs, okay? Again, that's the important part. That's the formula we're going to be using here. Half the sum of the intercepted arcs. So that implies that we're going to be using multiple arcs, two of them, adding them together, and then dividing by 2. Again, sum, add them together, divide by 2. Here we go, guys. All right. So first one, I've done it for you. Okay. So we're going to be able to pause and look back at this one, and then I'm going to give you some time to work these next two, and then I'm going to go over them with you. Okay. All right, so taking a look here, we have two secant lines, all right? Line UM and line QR that intercept right here, interior of the circle. So we're solving for the measure of angle 1. Now again, it's the sum of the intercepted arcs. Now what two arcs are you using? Well, think about vertical angles here, guys, okay? If measure of angle 1 is here, that means whatever this angle is on the other side is going to be the exact same thing because of vertical angles, okay? So because of that idea, guys, we're going to be using these two intercepted arcs, okay? Those are the ones that you're going to be adding together. Think about that vertical relationship, vertical angle relationship. Those angles are the same. So take those two intercepted arcs, add them together and divide by 2. That gives you the measure of the interior angle. So again, 50 plus 30 divided by 2, that's where we get 40 from. So again, the measure of angle 1 is 40. So that means this angle also is over here is 40. Again, vertical angles, they're the same, 40 and 40, okay? All right. Now, looking at number 8 here, guys, just kind of moving on. Don't worry about the numbers here, a little different. We did 1 through 6, we're not doing. So here, next example, all right. We look, we see we have measure of angle 1 and the measure of angle 2. Now, we really don't have anything to solve for yet with the measure of angle 2 because it doesn't give us any exterior arc measures, all right? Well, here for angle 1, we think about our vertical angle relationship. So these are the two intercepted arcs that we're going to be using, all right? So take those intercepted arcs, we add them together, 130 plus 150 divided by 2. That'll give us 280 divided by 2, all right? So what we end up with here is the measure of angle 1 is 140. Where did I get that from? Well, added my two arcs together, divided by 2. 280 divided by 2, 140, okay? So that's the new stuff for today. Excuse me. Now, when it asks us find the measure of angle 2, well, here's a little review, guys. We still have these angles that are adjacent. They come together to make this chord. Those are a linear pair. So to find the measure of angle 2, we're just going to go 180 minus 140. That gives us 40 degrees. Again, a little review there, guys. Linear pair are supplementary, okay? Angle 1 and angle 2 are a linear pair here. All right. Now in number 9, guys, let's take a look at this one. Now, this is going to be a solving backwards problem. So I'm going to give you a little time, okay? So right now, I already gave you the hint. It's a working backwards problem. I want you to pause the video and take time to work number 9 here, okay? Okay, now that you've had a little time to work this one, number 9, I'm going to go ahead and work it through with you. Again, solving backwards, it gave us the interior angle. Now we're going to find the arc measure, okay? So let's just set it up. We would add together our two arcs. So I have 140 plus x over 2 equals 120. Again, it gave us what we would normally be solving for. We're now solving backwards. Going to start by multiplying by 2 on both sides, all right? Okay, so I get 140 plus x equals 240, kind of getting here near the edge of my paper. All right, I'm going to subtract 140 from both sides to get x by itself. Okay, so x is just 100 degrees, okay? So there it is, solving backwards, guys, all right? Now it says measure of angle 1, measure of angle 2. That is a typo. Your answer here is x equals 100, okay? X equals 100, okay? And I apologize if y'all can hear my daughter downstairs. She's watching Sesame Street, and it is not amusing her. Okay, so now we're looking at where we have a vertex on the outside of the circle. So same thing here, except now the intersection is not in the circle, it's now out here outside the circle, okay? So we have three situations where this can happen, okay? Two secants, a secant and a tangent, and two tangents. But the rule is all the same, okay? When you have a vertex that adds out on the exterior of the circle, the angle is half the difference of the arcs, okay? So we're still gonna have multiple intercepted arcs, but now we're just gonna be adding them, or I'm sorry, the difference means subtracting, so we're going to be subtracting them, then dividing by 2, okay? So there we go, guys. Again, you can see here, this first example, I have it already done for you, all right? Now, we see measure of angle 1. Now, again, think about this angle like the alligator mouth. If that alligator mouth chomps down, it's going to bite off these two pieces of our circle. Those are your intercepted arcs. What arcs are on the interior of the angles? So here we go, guys. We have 120 for our big arc, 20 for our little arc. So that's what we're going to be subtracting. Again, subtract the smaller from the larger. 120 minus 20 over 2, that gives us 100 divided by 2, so that would be 50 degrees for angle 1. That's what we're doing here, okay? So two secants, it's pretty easy to see what the intercepted arcs are. Let's look what happens when we have a secant and a tangent, okay? So here we go, a secant and a tangent. Now, this point of tangency at point D, that's going to be important because we're still trying to find our two arcs. Our two intercepted arcs are our big and our small. Now, this point of tangency is going to be the dividing spot, guys, okay? So the big arc is going to be 180, okay, to the point of tangency, and I'm going to use just tick marks on this one. The little arc is going to be 60, okay? So you see I differentiated in the way I marked them. The squiggle for the big arc, the tick marks for the little arc, okay? Again, that point of tangency is what separates them, okay? Because a tangent line only hits at one spot, all right? So same thing here, guys. We're going to take 180 minus 60, okay, over 2. Again, we're subtracting because angle 1 is outside the figure, okay? 180 minus 60, that'll give us 120 over 2. So the measure of angle 1 is just 60 degrees. Pretty straightforward stuff, guys. You just got to know which arcs you're working for here, okay? Same thing with our point of tangency here. We got two of them because we're using two tangent lines. So point D down here would be my point of tangency. Point Q up here would be my point of tangency. So my big arc is going to be this whole portion going all the way around from my one point of tangency to the other. The small arc is going to be what's inside. Now, guys, the two arcs make up the entire circle because the alligator mouth would eat the entire circle here, okay? So what we know is measure of arc QRD, the major arc, is 240. The minor arc QD, well, that would just be 360 minus 240, all right? 360 minus 240, that's again going to give us 120 degrees, okay? So that's nice, all right? Now, same thing here. That's not our final answer. We have to take this. We have our 120 degrees. We have our 240, so 240 minus 120 over 2, okay? So 240 minus 120, that would give us 120 over 2, so the measure of angle 1 is just 60 degrees again, okay? That's just coincidence that the last two came together to make 60 degrees for our angle. But what's important to see here, guys, is what is the intercepted arc? When it's two secants, it's pretty easy to see. You can just see what's on the interior of the angle. When we mix in these tangents, you have to use that point of tangency as the breaker between your major arc and your minor arc. And when you have two tangents, the intercepted arc is actually the entire circle, okay? So from tangency to tangency, point of tangency, that's the major arc. Other side would be your minor, still subtract, divide by 2. That's where we get our answer, okay? Now, last little piece of these notes, guys, and this is important, and you can come back and look at this portion at any time, all right? If you want to take a little screen capture here, I'll try to get it to where you can have it all in it together, guys. Here's your 4 rules. The 4 rules of angles in circles. If the vertex is on the circle itself, this is called a central angle. The central angle is equal to its intercepted arc. So angle equals arc. If the vertex is on the circle, this is an inscribed angle. The angle is half the arc, okay? All right? Now these are the ones we talked about today. If the vertex is on the interior of the circle, you add the arcs, divide by 2, so half the sum of the arcs would give you the interior angle. The exterior angle is half the difference. So your your larger arc, subtract from that your smaller arc, divide by 2. That's where we would get our exterior angle. So again, guys, there's all 4 of your angle rules listed down at the bottom of these notes. If you want to take a little screen capture, might help you, okay? All right, so there's all the angle rules and circles. Use this when you're doing all your examples on the Khan Academy or the ALEKS, or covering each chapter, okay, of the circle portion of our textbook here. Hope you all are having a great day, guys. Again, call me or email me with any questions. Thanks. Bye.